So we're going to continue with functions, okay? And all of these happen to be linear functions. Okay, this is linear function. And this is part three. Okay, last week when we did the function tables, okay, at least part of it was provided for you, right? Okay, let's do a quick review of what a function is. Function has an input, but in order to have an output, it has to have a what? What's that? No. In order to have an output, it has to have a, what's that middle part called? The function rule, okay? The function rule. So if, for example, if I have something, well, your tables are going to look a little bit different today, okay? The only difference is, okay, this is the 12, 7, 3. Okay, my tables are going to look a little different in that I'm going to have an input. Make your own generic table. Okay, then I'm going to have my rule. Okay, the rule is kind of like what happens to the function engine. Then I'm going to have an output. And then the last one, I'm going to have an x, y value. Basically, that's a point. Actually, I'm going to put this. I'm going to put this. Okay, my output's going to be y. My input's going to be x. Okay, and then I'm going to have a rule. Okay, so let's make it a simple. Let's say it's y equals x minus 5. Okay, so here's the only difference though. Last week, you were given all of these inputs, weren't you? Okay, you were given the inputs, and then you use those inputs to find the output by using the function rule. Okay, the only difference is this week you're going to put your own inputs in. Okay, and then you're going to graph them. Now, if I have a graph, okay, what do you think a good idea is to do? Should I put? Would it make sense if I have to graph this? Okay, and I have a little graph, the little graphs on your worksheet. Would it make sense for me to put 25 right here? Why? This is going to be a big old graph, right? And I don't want to do that. Okay? So you can use whatever you want to, but I will suggest the following point. Okay? What's always the easiest one? Zero. Always put a zero. You could do a one. You could do a negative one. You could do a two. Okay? You can do a negative two. It doesn't really matter. But I want you to do at least 4 points. Okay? So this is 1, 2, 3, 4. You can do a fifth point if you want to. Okay? But you have to do at least 4 points. So if I was to use these 4 points, okay, I'm going to plug this in now. Y equals 0 minus 5. What's 0 minus 5? Negative 5. So my first point is going to be 0, negative 5. Okay, everybody with me so far what I did? Okay. What about over here? Y equals 1 minus 5. What's 1 minus 5? Negative 4. Okay, do you understand where this 0 and this 1 came from? Over here, these are my inputs that I plugged in, okay? Whatever you choose to plug into your input, that's what you should do. Okay, then I have y equals, what's my x this time? Negative 1 minus 5. Here's where we see mistakes. Okay, some people put negative 4 here. Okay, is that negative 4? No. Negative 6. And then my last one is y equals 2 minus 5, which would give me what? Negative 3. Okay. Now, obviously, this is a really simple example. This is a very easy function rule that I have. Okay, well, let's go back and let's go ahead and graph this. Okay, did you guys copy these down? Okay, so my first point is 0, negative 5. So I'm going to go over 0 and where? Down 5. So my first point should look like that, right? Okay, let's look at our next point. 1, negative 4. So over 1, down 4. Okay, next point, negative 1, negative 6. I'm going to go back 1 and down 1, 2, 3, 4, 5, 6. So far, am I all in line? Yeah, my last one is 2, negative 3. So over 2, down 3. So did I form a straight line with that group? Yes, I did. So did I do it right? Yes, I did. Question, Benson. Because because of the function rule. Okay, because every input that you put, it's gonna fall in line with that rule. Just as an example, let's just say that I made my x. Um, let's say for this one, let's say I made my x 9. Okay, if I did y equals 9 minus 5, what would that be? 4. Just to prove to that it's linear. If I go 9 fourths on my graph, I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, up 1, 2, 3, 4. That's still going to fall in line with all of those, isn't it? Okay? Does that make sense now? All right. So, what then? What do you think I'm going to do if I have a rule that looks a little bit different? In other words, if I have a rule like this, okay? Let's say here's my x, and my rule, here's my y, here's my xy. Okay, let's say my rule was something like this. Y equals x divided by 4 plus 3. Okay, what do you think I'm going to want to do here to make this as easy as possible on myself? Well, the thing is, if I use smaller numbers, I'm going to have to deal with what? Fractions. Okay, but if I use numbers that are divisible by what? If I use numbers that are divisible by 4, is that going to create an easier situation for myself? So let's just say the first one, Mikey, pick a number that's divisible by 4. Let's go small. Okay, if I do 8, okay, so y equals 8 divided by 4 plus 3. What's 8 divided by 4? 2, and 2 plus 3 would give me what? So that's a doable point. What if I did 4? Is 4 divisible by 4? So if I do 4, y equals 4 divided by 4 plus 3. What's 4 divided by 4? And 1 plus 3 is 4. Okay, what if I did, let's say, negative 4? Okay, y equals negative 4 divided by 4 plus 3. What's negative 4 divided by 4? Negative 1, and what's negative 1 plus 3? 3. Okay, and for this last one, again, what's always the easiest one? 0. 0 divided by anything is what? 0. What's 0 plus 3? Okay. Now, I can use, like I said, I can use whatever. If Mikey said 12, if I had decided to use 12, I still would have gotten the correct answer. It's still going to be on that line. Okay? But you can use whatever one you want. So let's graph this now. 8, 5 is my first one. Okay, so over 8, 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, 3, 4. Okay. Right about here. What's my second point? 4, 4. So over 1, 2, 3, 4, up 1, 2, 3, 4. What is it? Negative 4, 2. So back 4, 1, 2, 3, 4, up 2. And my last one is over 0, up 3. Over 0, up 3. Okay. Did it work? Good. The line goes right through all those points. Okay. Does that make sense? So let's say on the bottom, what if I had a 7 on the bottom? What would it make sense for me to do? Plug in numbers that are divisible by 7. You just have to think a little bit about whatever input you want to use so that your result is, number one, not too large to fit on the graph that you're given, okay? But number two, easy to work, okay? If I had chosen over here, let's say I chose 2, okay? I would have had y equals 2/3 plus 3, okay? Well, this gets a little more complicated, doesn't it? What I said. What's 2/4? See? Exactly what I said. 2/4 plus 3. So if I have something like this, I can still do it, okay? But do you understand what it makes it easier if you have a number? You choose a number that's divisible by that bottom number. Agreed? Okay. Does this make sense? Okay. Question. You could use multiple, like 14, 21, 7, 0. Okay. I would, just a word of advice, I would include 0 in every single input every one of that you have. Use 0 for one of them. You can use 1 if you want to, but if I had used 1 here, it would have created a fraction. Okay. Which, when you're adding these numbers, is easy, but if it was let's say it was x over 4 minus 2. It creates a problem if you have 1/4 minus 2. It's a little bit tricky. Okay? Yes, question. Just about, yeah. Okay, I'm going to write, you guys make a table for me. I'm going to write a rule. Let's see if you can do this correctly. Okay, complete this table for me. Y equals negative 2x plus 1. Okay, let me see. Carson, give me one of the points you chose. 1. Okay, so y equals negative 2 times 1 plus 1. What's negative 2 times 1? So negative 2 plus 1 will give me what? Negative 1. Good, so I got 1, negative 1. Okay, Mikey, give me one of the points you chose. 0. Okay, so y equals negative 2 times 0 plus 1. What's anything times 0? So 0 plus 1 is? Okay. Mandy, give me one of the points you chose. 2. Okay, so y equals negative 2 times 2 plus 1. What's negative 2 times 2? Negative 4 plus 1 is? Okay. Angela, give me one point you chose. Negative 1. Good. How many points do I want you guys to choose for each one? 4. Okay. So y equals negative 2 times negative 1 plus 1. What's negative 2 times negative 1? Positive 2 plus 1 is? 3. So negative 1, 3. Okay, let's go graph these. Let's see if we did them right. Okay, the first point is 1, negative 1. Okay, so over 1, down 1, is that right? Okay, next point is 0, 1. So over 0, up 1. Next point is 2, negative 3. So over 2, down 3. Looking good so far. Last point is negative 1, 3. So back 1, up 3. So did I form a straight line? Yes. How many of you chose a point other than the 4 that we chose that we talked about? Okay. Did it still fall in line on this graph? Yes. Okay. Does everybody understand how this works? It's not that difficult. Okay. On your worksheet, the first 2 problems, your table is given to you and your values are given to you. The last 6, there's only 8 problems today. Okay. The last 6, you've got to make your own table. If you can fit that table on this worksheet, fine. But if you can't, put it on a separate sheet of paper. Make sense? Make sense. Okay. Mikey, question.